Hi, this is Andre with a new video. So far, we have mainly created static scenes. Today, therefore, it's about how we can breathe some life into our virtual worlds. One way to do this is through animations. This is the first video in a short series. First, I'll give you an overview of the various components of the animation system. And at the end, we'll learn how to animate individual objects or object hierarchies. Unity offers an animation window, for example, where you can animate individual objects or smaller object hierarchies. For instance, I can animate a cube, like this one, so it continuously rotates. You can think of this a bit like video clips, which are later edited together into a full movie. We can create individual animation clips and later merge them into larger animation sequences using other tools that Unity offers. One of these tools is the timeline, which allows me to create more complex boundaries from several individual, previously created animation clips. On one hand, I can animate individual objects over time, for example, this cube, which first rotates, pauses, and then continues to rotate. But I could also animate several objects simultaneously and thus create complex choreography. The whole thing is quite similar to video software. There are tracks where I can animate these individual objects. Additionally, there are some special tracks, for instance, to bring in audio or to animate some more specific Unity properties. The timeline, compared to a few other Unity tools, is time-fixed, meaning it's more suitable for fixed sequences, such as cutscenes in video games. As an alternative to the timeline, there's the animator. It allows you to control complex, interlocking animations. For instance, it makes sense to animate dynamic characters, such as computer opponents in games. They have various animations. They can walk, jump, crawl, shoot, hide. And with the animator, you can control which animation can transition into which other, and how long these transitions take. These different systems build partly on each other. For example, the timeline and animator rely on the clips, which we created earlier in the animation window. These clips and other elements like timelines and animations created by the animator are saved in the project as files, meaning once created, they are reusable and can be transferred to other objects. Meaning, I don't have to create animations for each object from scratch, but can reuse them, thus saving work and time. Additionally, there's the Cinemachine. It's actually a tool for camera settings and camera moves. It offers, as we see on the right side, so-called dolly tracks. They are also known from film production. Basically, they are just paths that the camera follows. Fortunately, these dolly tracks are not limited to cameras. They can actually move any object. Thus, I can use them, for example, to animate swimming fish or skiers on a slope. In this video, we will first focus on the animation window and the creation of simple clips. As said, with the animation window, you can create and edit clips, but you can also represent clips from external software, like animations made in 3D programs, such as 3ds Max or Maya, or motion capture recordings made in a studio, similar to common video editing software. It deals with keyframe-based animation. A keyframe is basically just a point in time at which we assign a fixed value to an animatable property. You see it here on the right side. These are the diamonds between two keyframes, where Unity calculates the values itself. Basically, an interpolation or in-between calculation. In this example, the y-axis rotation is animated. And there, a keyframe at second 0 is set to 0 degrees, and at second 1 to 180 degrees. In between, Unity calculates everything itself, for example, exactly at the midpoint. With the animation window, as said, you can not only animate single game objects, but whole object hierarchies. We see this on the left side. There, an industrial robot arm is animated, consisting of many individual parts. For example, the main body, the main arm, the hand, and the individual robot fingers. On the right side, we see the keyframes in the form of diamonds. In Unity, it is so that every component can have animatable properties, even scripts that we develop ourselves, like in this example, the ball script, where we can animate the energy of the ball. Whatever that means. However, it is so that only certain data types can be animated. Usually, they are simple data types, numerical values or groups of numerical values. Like in this example target. What I haven't shown you yet is that the animation window has several display modes. On one hand, we have the keyframe mode. We already know that one. The keyframes are represented as diamonds there. It has the advantage that the temporal sequence is very clear. But on the other hand, we don't see very well how the values change over time. Besides, there is also the curve mode. The value changes are very visible there. And I can also control the interpolation between two keyframes very well, whether it's more like a curve or linear or sharply chopped off. However, it is very unclear when many properties are animated simultaneously. Enough of the theory. We jump right into Unity. And I'll show you how to animate simple objects, in our case, a small car. Now we want to drive around in circles. Of course, we first need to open the animation window. I do this here above via window. Animation. You see, even under Windows, it's the shortcut. Control 6. Then it first appears here in the middle. I like to drag it down to the bottom. And from here we can now create our animations. To make the car animation capable, I click on it first, creating the necessary components for you. At the beginning, it creates an animator and animation clip. I press create here. Then it asks me where I want to save the animation. Of course, we sort everything well and name it, for example, simply car ride, and save it. As you see, if we hide the unimportant components, it has created the animator component here. An animation controller named K is also linked. It also automatically created it according to the name of the game object. Currently, he just throws it somewhere. And that's right next to the newly created animation. Here in animation, this is the controller. And if we want to sort it a bit better, into animation controllers, now that we've created it once, it no longer asks us for create. If we want to create additional clips for the same object, then we can here, where you see the name of the current clip, create a new clip, creative clip. Then he asks you again where he should save it. Of course, we can also create all these elements, which he just automatically created, all individually. For that, I would first need to create the animator over a component. It's already there, so I'm not doing it now. I could create an animation controller in Assets. By create an animation controller, I would then have to assign it here to the animator. And then I could also create an animation here via create animate. From the camera view, it's a bit difficult to animate the car. That's why I like to switch to the top-down view. And also make it an orthographic camera. That means that the camera is not perspective. You see everything a bit better. Unity offers several ways to animate objects like our little car. On one hand, we have the recording mode, it's here. This red button, with it Unity always automatically sets frames as soon as an animatable. On the other hand, we can also manually set keyframes. But back to the animation window. And the keyframes are always set at the point in time where this little white beam lies on the timeline. If I now, for example, go into the recording mode and move my object, you see that these diamond-like keyframes are set for our property position, the one that I just changed. If I now go to another point in time, 0.3 for example, and move the car again, the position is changed again. In between, Unity calculates the values itself, as mentioned. We can also use this little playback here to watch our work in a loop, to examine our creation. An interesting point here is that we don't need to switch to the play mode above to watch the animation, but the preview also works just fine in the editor mode. But let's continue with our animation. We now jump to the next point. Let's say 1 second. We are still in animation mode, so it creates the keyframes there itself when I set them. For example, I want to move the car here and also rotate it. Voila, all by hand. Now, first of all, the values are not exactly precise, but that's not always so important. And now we notice that something happened that we actually didn't want. Namely, if I jump back a bit, he pulls the rotation all the way to the start. This is because we only set a keyframe for the rotation at this point in time. You can see here in this middle keyframe, there's nothing for rotation down here yet, so we have to fix it. Either we go back and turn it right here, then he drives straight here. All of that can be fixed later. So, we now have an animation where he drives a bit and turns the corner. Unity tries to support you visually, of course. We see the color red. We are still in record mode. And in this mode, all properties that we animate in this clip are also highlighted with a dark, hard to see background. When we leave this mode and go into the normal preview mode, we see them mostly in blue. And all animated properties are also highlighted in this blue background, so we can distinguish them from the non-animated properties, like scale. I can also set keyframes outside of record mode. For that, I simply jump to any point in time and set the x-coordinate of the position to -6. You can see, Unity also visually supports us here. The changed property is highlighted in dark red again. Outside of record mode, it's now so that I have to set a keyframe immediately before I move this time arrow again. Otherwise, I lose the information. I can just do it. I have set a bit here. Here we were just now. Now we are back here at -6, 20. So the information was not saved in between. If I want to do this, there are several different ways. On the one hand, I can simply click on the position and say add keyframe. This means that Unity creates new keyframes only for this property position. You see, rotation remained the same here. I'll undo it for now. It doesn't work. Yes, it does. I can also say add modified. This means that he sets a keyframe for all modified properties at this point in time. All modified ones that are already in the clip. This is currently only the position, so it comes to the same result. I can also say add all animated. This means that all animated properties we see below, position and rotation, get a keyframe. Sometimes we want that. And next to that, there are all animate. This means that all animated properties we see below, so position and rotation, get a keyframe. I'll just do it. In other situations, we don't want that. You see, all of them have been added here. You can achieve the same effect without going through the inspector, but by pressing keyframes here above the small red symbol with the plus. And to show you a few more ways to do exactly the same thing, you can also directly enter values for different times here through this value view. So if you, for example, jump to an existing time, you could simply change the value from 0.2 to 0.3. Then you only see that the shadow has changed because I lifted the car a bit upwards. You can also go to a completely arbitrary time and create a new keyframe there by simply changing the value. And you see, here he even makes it more punctual than when I only filmed the position as an edit really only for this one coordinate, which can sometimes be quite practical. I'll just leave it like that. You can also, instead of going here through these properties to set keyframes for new properties, or through the recording mode, also here through add property existing properties of the different components take, and add these as well. For example, I could take something from render here, for instance, the color, and change the color over time using animations. So far, we've come to set a small part of the track already. But to make a full round, we need more time, and for that, we just have to turn the mouse wheel within the window, and can thus stretch and squeeze the time. We can also undo the whole thing again. For this, there are a few very helpful hotkeys. For example, I can use a to stretch the entire animation to the length of the window, or if I select part of the animation with mouse drag and drop and press F, I can just stretch that part. This is especially practical for long animations. Sometimes, if you want to bring the things you're currently working on a bit more into focus, that's why also F for focus. I zoom out a bit again and go into the recording mode, as I think that's the easiest mode to perform such a small animation now, if not the most perfect. I go a bit further in my timeline. For example, half a second. Pull the car to the spot where I want it. You already see, he just set the position as a keyframe so that the rotation doesn't happen again. From here, I set a keyframe for the rotation as well, etc. And now, if I jump to the next point, 477, pull the car down and rotate, and here he then sets both keyframes correctly. So, I have the rotation really only on this part, and I do that now continuously further until we've gone around once. You can just watch me now for a short moment. And now we're roughly where we started. I exit the recording mode, and we can take a look at it here. You see, he's sometimes a bit faster, sometimes a bit slower. That's one of the complexities that animation in Unity brings with it. If you want it very precise and very smooth, so to say, you have to invest quite a lot of time. We have one small problem left, which is that the start point and end point are not exactly aligned. I managed to get the car pretty close to its starting position, but when you loop the animation, you'll always see a little glitch where the car kind of teleports. It wasn't too noticeable here, but what you can do if it becomes more noticeable is to take this last keyframe. You can use the top bar to select all keyframes at this point. Select them, and then delete them. Then take the first keyframe and copy it with Ctrl plus C. And paste it back in with Ctrl plus V. Now the start and end points are exactly the same. So when I play it in a loop, you shouldn't see any glitch. Except that it now makes a full rotation. But we'll take care of that in a moment. The issue is that I copied the first keyframe, and its rotation is set to 0. While the previous one was set to around 360. So it makes a full rotation. To fix this, we just need to set the last frame to 360 instead of 0. Now when we play it, it should make a complete circle correctly. It ends at 360 and starts again at exactly 0. But since 0 and 360 are the same, it works. Sometimes it's a bit hard to hit these exact values. You might expect that if I click here and enter a value, it will change the frame, but it doesn't. Instead, it creates a new frame, which we don't want. There are a few keys to navigate more easily. To move between keyframes, you can use Alt plus comma and Alt plus period. With comma, I go back. With period, I go forward. These functionalities are also in the UI. We have next and previous keyframe buttons. When we play the animation again, not only through the play button, but also with the space bar, we see that it stops briefly at the end before moving again. We can take a closer look at this in curve mode. The reason for this is that the interpolation between keyframes is not linear but has a smooth curve, reaching maximum speed in the middle and slowing down at the end. To fix this, we need to tell Unity how to interpolate between keyframes. This can be done with tangents, which control the curve behavior at a frame. You can see the curve change when I move it. But this is not exactly what we want. So I'll undo it. What we want is a straight line between points, so the speed is constant from start to end. To do this, I zoom out, select all my keyframes, and use Unity's preset. I right-click and set both tangents of all keyframes to linear. Now the curve is more angular. And when we play it, it works as we want. It maintains a consistent speed. Throughout the animation loop. Now the animation is roughly as we want it. And view it from another camera angle. Now it continuously drives in a circle. However, sometimes you have animations that should not loop. This must be set specifically. In the animation, I go to my project, View, find the animation, and here we have the loop time setting. If I turn it off and play, it will do the animation once and stop. Done. So far, we have learned how to add a single animation to an object. Of course, some of your objects will have multiple animations, so I'll show you how to manage them. This is where animation controllers become important, which were automatically created earlier. It created this car controller and linked it to our animator. Let's take a closer look at it. I'll double-click on it to open the animator window. We see a graphical representation. Animation controllers are a complex topic, but briefly, an animation controller determines which animation an object is currently performing. In our case, our object only has one animation, so it plays by default. The graphical representation you see is for a state machine, which controls the different states of a system. To illustrate this concept, I need a second clip, so I go back to my scene. Select my car, go to the Animation tab. And create a new clip using the Create New Clip menu. I name it Move Forward. And make sure it's in the right folder. It's empty at first. Now I quickly create a small animation in recording mode. To make it move forward, when we go back to the animator, we see that this machine has a new state, Move Forward, which is not yet connected to anything. So when I start play mode, the car will still perform car right. And that's what happened. If I want the other clip to play, I set it as the default clip in my state machine. I do this via the Set as Default menu. Now it will always move forward, and then reset. Animation controllers become more useful when you program and control the transitions between animations. In this simple case, I can also say, I want the car to make a turn and then move forward. I set car right as the default animation and create a transition to the forward state. When we watch this, the car should make a turn and then move forward. And it repeats because it's set to loop. That's it for the first video on animation. You should now know how to animate simple objects using the animation window, and maybe how to sequence multiple animations using an animation controller. Always make sure if looping is enabled or not. The next video will cover the timeline. For all these videos, at least in the animation series, we have a PDF with additional information, such as tools you can use, and special animation modes like the rig mode.